This is the question number 6 on your handout, and the question goes, .487 grams of quinine with a molar mass of 324 grams per mole is combusted and found to produce 1.321 grams of CO2, 0.325 grams of water, and 0.042 grams of nitrogen. 0.0421 grams of nitrogen. Determine the empirical and molecular formulas. The first step in solving this question, I took the liberty of increasing all the quantities 1,000-fold. And for the simple reason that I didn't want to write exponential. I preferred to write numbers with a couple numbers before the decimal place. That's just an idiosyncrasy that I have. So what I did is I increased all the quantities to 487, 1,321, 325, and 42.1. So all that does is scale up the experiment equivalent. Then I wrote the combustion equation. This is what happens in a full combustion, in a complete combustion. A substance is burned, and the substance that we're burning definitely has carbon because CO2 is produced. It definitely has hydrogen because water is produced, and it definitely has nitrogen because nitrogen gas is evolved. I put a question mark next to the oxygen because I'm not sure if it has oxygen in it. We'll find out after we do the calculation. Oxygen is added to provide the oxidizing medium, and then we get those three products. We measure the mass of CO2 produced, the mass of water produced, and the mass of nitrogen produced. We divide by the molecular weights of each one of these molecules. So carbon dioxide has a molecular weight of 44. Water has a molecular weight of 18. We don't have to do it for nitrogen because they tell us right off how many grams of nitrogen is produced. And nitrogen is the only substance produced. It's not produced in combination with another atom. The whole purpose of this calculation is to find out exactly how much carbon is present and how much hydrogen is present. So we divide, once we find the number of moles of CO2, we can infer that it's the same number of moles of carbon dioxide because each mole of carbon dioxide will have 1 mole of carbon with it. We multiply by the molar mass of carbon alone to find out the mass of carbon, which is 360 grams. We do the same thing here, but with one extra step because water has a 2-to-1 mole ratio of hydrogen to water. So there are 36 moles of hydrogen, which turns out to be 36 grams of hydrogen. We then add the three quantities of carbon, hydrogen, and nitrogen to get a total of 438 grams. And that tells us right away that there's some other element we haven't accounted for. 438 grams accounts for the presence of carbon, hydrogen, and nitrogen, which must mean there's some oxygen in the molecule. So the missing weight, 438 subtracted from 487 tells us the mass of oxygen that was in the original molecule, 48 grams. We then proceed to calculate the percentages of the percentage composition of the quinine molecule. So it's 74% carbon, 7.47% hydrogen, and so on for nitrogen and oxygen. And then we assume a 100 gram sample, which allows us to divide by the molar masses of each one of these substances to find the ratios. We then divide by the smallest number in that ratio to find out whole number ratio of the elements involved. So it's 10, 12, 1, 1, which gives us the empirical formula of quinine. We are also told in the question that the actual molecular weight of quinine is 324, which does not match the empirical weight that we've calculated. However, it is exactly twice as much. So that infers that we should multiply the empirical formula weight by 2 to get the actual molecular formula. And so 2 times the empirical formula gives you the actual formula of quinine, which is C20H24N2O2.